So hello everyone. Uh, it's been half an hour since the contest got over, and I saw that many few people were actually able to solve the question C and D. The fact that D was itself solved by only 8 people in Div 2 was like really shocking. It is a really simple question, and C as well. C was solved by 240 people. So uh, I wish to solve A, B, C, D today and explain those as well. And before, like, it's not worth it to solve A, B first and then go for C and D, because many of you must have already solved A and B. Let's start the reverse way today. Let's start from the D, and then let's move on to slowly the easier problems and finish up until we reach A. All right. So question D was possible contender. Since 8 people only solved it, I don't expect you guys that you have already read this question. So I'll explain the question first, and then we'll move on to its solution part. The question states that you're given an array of n integers. Okay, the array element can go up till 1e9, and the n will obviously be less than equal to 1 if 2 if I. All right, 2 into 10 power 5. Now, given the array of n integers, what you can do is you can choose any uh, subarray from L to R, such that the length of subarray should be greater than 1. You choose this subarray and you replace this complete subarray with its median. All right. I hope you already know what a median of an array is. So basically, when you sort the array, the n by 2th element is the median of the array. For example, median of 3 to 1 is 2. The median of 1 4 1 4 2 3 is 2 as well, because we need to sort the array first and then take the n by 2th element. All right. Now moving on to the question, what you do, you choose the subarray of length greater than 1, and you replace that subarray with its median. Okay, why are we doing this? And you can do it as many times you want, why are we doing it? Because our target is to check whether for all a of i's, is it possible to make the array of length 1 and only contain a of I. Okay, is it possible to compress the array to only one element, and that to a of I? So we need to tell it for every a of I present over here. All right. Let's take some sample example and figure out. So let's take this example, double two double three, 4 double 2 double 3. Now, can we make this whole array only 2? Can we? Let's check it out. Okay, first what I'll do, I'll take this subarray 2 comma 3 and I'll change it with its median, which is 2. So this array will become 2 2 and 3. Now I'll take these two elements and replace with its median. Now the array will become 2 comma 2. Now I will take these two elements and replace with its median. The array will become only 2. So yes, I can make this array 2. So the answer for 2 will be 1. Obviously this is 2 as well. So the answer for this 2 will be also 1. Can I make this array 3 is the question now. So to check that, let's take the array again, double 2 double 3. Now Now, if I want to make the array 3, what I'll do, I'll take these 3 elements and I'll change it to its median, which is 3. Uh, so it will be 3. All, all right. So, and then I'll take the median of these two, which will be 2. So can I make this 3 this way? No, I cannot. So I need to think of some other way. Okay. So let's take 2 2 3 3, and now I'll replace these both 2 with their median, which is 2, and now the array becomes 2 double 3, and then I'll replace it with its median, which will be 3 only. So thus I can make the array 3 as well. So the answer for both of these will be 1 as well. So if such case comes when the answer is not possible, we write 0 there. Okay. For example, let's say there is a 4 here as well. It is not possible to convert this what we say, the array's median to 4, no matter how we perform this operation. So here will be 0. Now we need to figure out a way to come up to this solution. How can we identify whether we can make the array contain only one element and that element should be a of I. Okay. First, let's observe couple of things. Observe. Number one, since we are allowed to take any subarray of length greater than equal to 2, let's take the subarray of length 2 itself. What can we see here? So whenever there are two elements a common b in subarray, the median will always be the smaller element. Am I right? The median will always be the smaller element. So let's let the smaller element be a here. So the median of this a comma b will always be a. So we can always erase large elements. Okay, we can always erase large elements. So number one observation is we can always erase large elements, or to be precise, larger elements. Okay. Observation number two, for a number to be a median, it should occur in it should be present in the center of the array when the array is sorted, or the subarray when the subarray is sorted. For it to be present in the center, the number of smaller elements should be less than equal to number of greater elements. Why so? Why so? Why the number of smaller elements should be number of less than equal to number of greater elements? Let's assume that number of smaller elements are less than greater elements. Let's say our target is b. Let a be a smaller element b, and let there be a lot of c and d's which are greater than b. I can always reduce this C and D's to a single element by taking subarrays of size 2, because our first observation says that we can always erase the larger element. So in this D's I will keep only one D. In CD I'll keep the D. I'll erase the larger element. I keep only C. So similarly I'll keep only one large element and one small element, and thus a b can be the median of the array. Got it? So the number of smaller elements should be always greater than equal less than equal to number of greater elements, because I cannot, if a is smaller than b, I cannot delete this a any further, right? Because if I choose a and b as the subarray, b will get deleted and the target will get lost. We won't be able to delete the a, right? So I can only reduce the greater elements. Now observation 2 was smaller element should be less than equal to greater element, and if we do not include our current element b, then smaller element should be always less than greater element. Okay, that then only we can comparatively to target, then only we can make this possible. Okay, so these are the two observations. Then the third observation, our answer is monolithic, sorry, monotonic. What does this mean? So if 3 can be median of array, 3 can be median, then 1 and 2 can be medians as well. How? Let's say there are this is as a array where 3 is the median of the array. Okay. Now, since I have the opportunity or the advantage of deleting the greater elements, I can always delete this 3 and 4 and just keep 1 and 2. So here, as you can see, 1 will be the median. Similarly, I have the authority to delete this 2 as well, since it is a greater element, and only keep 1. And or I can, or what I can do is select these ones and delete these 1 and keep only 1, and I can delete this 1 and 3, can delete this 4 by choosing 1 and 3, and now as you can see 2 is the median of the array, or I'll choose this, and as you can see 2 is the median of the array now. So similarly our answer is monotonic. So what can we deduce from this? We can binary search on our answer, right? We can use binary search on our answer. Now, so our after these three observations, what we can conclude our approach is to uh, use binary search to find maximum element which is eligible to be median. Every element less than equal to maxi will have the value 1, because they can be median as well. Every element greater than maxi will have the value 0 because they can't be the median. So this is how our result string will be created. If you want to see, now before that, I like you to explain how can we check if the count of smaller elements is less than count of greater elements. Let our array be 1 1 3 4 2 and let our target be 3. Now we want to check what is the count of smaller elements and what is the count of greater elements. Since I want to reduce the number of smaller elements, I'll try to reduce them as much as possible. Since my target is 3, I can combine this 1 1 and replace them with a single one because that is its median. Alright, so let's say here is 2 1 2 3 as well. Let's only this 3. Now I can combine this everything and I can replace it with its median, which can be 1. So I can replace every continuous sub array which has all elements less than target to a single element. Therefore, therefore, number of smaller elements will equal to number of sub arrays with value less than target. Got it? Got it? This will be the minimum number of smaller elements. Similarly, you can find greater elements as well. You don't need to compress the greater elements. You can directly count them because we want them to be as much as possible. And you can check these conditions. If you want to see the code for this one, it is this way. So I set low to 0, highs to 1 in 9, and I'll find the maximum possible value which satisfies or which is eligible to be medium. So I find the sub array by increasing the count. If I get an element which is greater than equal to my target element, I check whether the count is greater than 0, and if yes, it is one of the valued small element. I'll set the count to 0. I increment the large. So I'll check whether the small is less than the larger value, and similarly I'll find the maximum possible value and store it in the answer variable. Every value less than equal to answer will have a 1, else it will have a 0. If you don't understand the solution, please do watch the video again. Do focus on the part where you felt that it is going a little tougher. Go through the question, dry run a few tasks, and I'm sure you will understand it. The question was not that hard. Okay. Moving on to perfect prefixes. Now there are various solutions to this question. Some of them include DP, some of them don't. We can also solve this question greedily. I'll like to explain what my approach was to this question. Okay, so let's start again with some observations and then we'll write our approach and then I'll show you the code. I hope that's all right. So now uh, let's understand what the observation is. I hope you have read this question. If you're not, please read this question once because I think like since 250 people have already solved this question, I hope that you have at least gone through this question once. I'm not going to explain the question. I want you to go and read the question itself. Okay, so let's take a sample test case and understand and get some observations here. So since we want to choose an even length subarray or even length subarray, we can decide L to be even or L to be odd here. All right, L can be even or L can be odd. So if this is array 3 1 4 2 5, you can break the array in these parts like 3 1, this pairs 4 2 and 5 since it doesn't have a partner, or these pairs. Okay, so you can divide it in such pairs that L is even, that is the starting index is even, or you can divide it in such a way that L is odd. You can do it both the ways, and both the ways are fine, and you need to try both the ways for the solution because we are working in a greedy fashion. Okay, so let's assume this way and this way. We only have two options. Second, this is our first observation. L can always be even or always be odd. Okay, for I'm talking about L of every pairs, not the complete subarray that we are going to select. Now let's say there are few more elements here, 7 8 10 12. So these will be the pairs. Okay, these are the pairs. Now you have to select some pairs such that they are continuous. Like you cannot choose to swap this thing and ignore 5 and 7, because you can only perform one operation and you need to choose a continuous sub array are always continuous. So either you choose everything or you choose any one sub array. You cannot like choose pairs and take some gap and then choose pair again. You cannot do that. So you need to, so basically you need to choose every pair which is in continuous fashion. You cannot get the discontinuity here. So now let this be our actual array: 3 1 4 2 5 7 8 10 12. Okay, now we will calculate prefix answer for this before any swaps are taken. Is 3 a complete permutation? No. So the prefix answer is here is 0. Is 3 1 a complete permutation? No. Is 3 1 4 is a complete permutation? No. Is 3 1 4 2 is a complete permutation? Yes. So the answer is 1 here, because all elements from 1 to 4 are present. Is 3 1 4 to 5 a complete permutation? Yes, because all elements from 1 to 5 are present over here. Is this a complete permutation? Actually, there need to be some more elements, 6 and 7. Let's omit this 10 and 12 for now. Let's replace it with 6 and 7. 5, 8, 6 and 7. All right. Is this a complete permutation? No, because we don't have a 6. Is this a complete permutation? No, because we don't have a 7. Is this a complete permutation? Yes, because we have all elements from 1 to 8. So this is our prefix permutation. Prefix of complete permutations. Now, when you decide to swap these two index, when you decide to swap these two index, answer of this will never change. Okay, answer of this will never change. The only change will be the answer of prefix here and prefix here, or henceforth. Okay, so you can always choose the answer of prefix of I minus 2. This will always be there. Now you need to add the delta change. Delta change is basically what happens when you swap these two elements. If you look carefully here, when I swap these two elements, the array will become 3 1 4 2 5 6 8. Okay, and the prefix array will change. Change why? Because this is now a complete permutation. The one, it will come one here, and since this is not a complete permutation now as well, so it will remain 0. So our delta change is positive 1, because our number of prefix permutation increased by 1. Okay, our number of prefix permutation increased by 1 here. Similarly, let's say this was the initial array and I decide to swap 5 and 6. Okay, if I decide to swap 5 and 6, let's say this is the initial array, new initial array. So if I decide to swap 5 and 6, I know if since I have swapped 6 and 8, I cannot swap 6 and 5. Let's just assume that this is a new array. Okay, so now as you can see, this is not a complete permutation, so the value will go to be 0, and this will still be 1 because this is a complete permutation. Now the delta change is -1 since we lost one uh, complete permutation. Similarly, for every odd length of odd pair where L is odd, we'll calculate what is the delta change. Let's assume this is plus A, this is minus A, this is plus B. Let A be some values. This is minus C. So these are some delta change. Okay, I can choose any one subarray from here, any one subarray, but that subarray should generate as much positive sum as possible, because I want my answer to be as large as possible, right? So to have as much positive as from the given set of elements, like plus, from plus A, minus A, plus B, minus C, to have as much positive sum as possible, I need the maximum sum subarray, maximum sum subarray, which we can get through Cadence algorithm. If you don't know Cadence algorithm, please go and look into it. So we'll use Cadence algorithm to find maximum sum subarray after this subarray, if after these values are generated, and I'll do the same process for even length pairs as well. I'll find any one maximum sum subarray. So my final answer will be prefix of n minus 1 plus odd wala maximum, comma, prefix of n minus 1 plus even maximum, the maximum of these two will be my final answer. Max of these both will be my final answer. And of course, and maximum of prefix of n minus 1. It might be the case that both even max and odd max are negative. So maximum of all three values will be my actual final answer. Since it might get a little tougher, I want to dry run a particular test case. Let this be the test case, all right? So 3 1 4 2 5. So now when I, what is the initial prefix array? 0 0 0 1 2. So this is the initial prefix array. Now let's consider some even length elements. 3 1 4 2 and 5, since it doesn't have any pair. uh ठीक है? Now odd L basically. So now when I swap this, what will happen? When I swap this, 1 will come here, 3 will come here. So my prefix array will change to something like this. So this is a positive delta change. So this value is plus 1. Okay. And when I swap this, what will happen? When I swap this 3 1 2 4. So what will happen? So this will be 0 0 1 1. So again I got a positive delta change. Here it was 0 and now it is 1. So I got one more positive change. So my final array will be 1 comma 1, and the maximum possible sub array sum is 2 here. Basically I can select both here. So my final answer would be prefix of n minus 1 plus 2, which will be 2 plus 2, which is 4, and which is the correct answer. Now for a moment let's assume that I choose the opposite even length, uh, what we say, pairs, even L pairs. So what will happen now? If I swap this, it will become 3 1 4 2 5. Now the answer is 0, the answer is 0, the answer is 0. Sorry, it is 5 here. The answer is 1 and the answer is 2. So if you observe carefully, it did not change at all. The answer did not change at all. So this is a 0 delta change. And if I swap that two pairs, 3 1 4 5 2, now the answer is 0 0 0 0 minus 1. Sorry, 0 0 0 0 and 1. So this is a minus 1 delta change, since it was 2 here and now it is 1. So this is a minus 1 delta change. So if you like create the array of it, the maximum sub-array sum will be 0, and the answer that will be produced here will be 2 only, because it is prefix of n minus 1 plus 0, which is equal to 2. So when you take even part, you got the answer 4, and when you took the odd indices, you got the answer 2, which 4 is maximum, so the answer is 4. Similarly, you can dry run through other as well, other test cases as well, and you will be able to see the pattern as well. So before you see my code, I want you to try this yourself. You can see my code in the description. If you are not able to solve it, if you're not able to understand, do watch this questions tutorial again. Moving on to second question, since 1800 people were able to solve this, I would definitely not like to go in details of this question, and I again assume that you have read this question beforehand. So since tower's height hp, tower's height k is seconds allowed, and n is limit of a comma b. A comma b should be less than equal to n. Observation number observation number 1. Observations basically. First observation, b should be always less than a, because if b goes greater than a, you will fall more than go up. You will always you will have negative change, and you will always go down, you will never go up. For b to be greater than equal to a should be greater than equal to h, because if you can directly go from for one, if you can directly reach h in one jump, you don't care what b it is at all. So we can 2.2 will be, if a is greater than equal to h, b can be anything. So b can be from 1 to n. So b has n possible values. So these are, and now the only case remains is if a is less than h. Okay. So number of seconds reach to go to the top will be always be equal to h minus a upon a minus b plus 1. So k should be strictly greater than h minus a upon a minus b plus 1, actually greater than equal to. Since a is less than equal to n, you can loop and traverse all possible values of a, all values of a, and find what are possible values of b for that given a. Okay, so you have two options to find b for given a. You can either like shuffle this and create a formula for b should be less than equal to, or you can simply use binary search to find what is the maximum value of b. And that, let's say you implement this find b function or count b function where you pass a, and this function will return the number of b's, return number of possible b's. So your final answer will be for a in range 1 to n included. If a is less, if a is greater than equal to h, answer plus equals n, else answer plus equals find or count b or for that given a. So this is basically the approach for the second one. Solve, try it yourself if you haven't done this before, and if you're still unable to understand, do refer my solution. Okay, contest. Moving on to first question, that is redundant array. I don't even remember what this question is. So basically you can choose any sub array and multiply it with any given constant, any constant value that you want. That must be positive, of course. The cost will be r minus l into 1 plus x, and you need to find to minimum cost to convert all the elements to same element. Basically make all the elements same. So as simple as that. The worst case cost will be n, because you will choose l from 1 to n, like l is equal to 1 and r is equal to n and x is equal to 1. Thus n minus 1 plus 1 into x, which is equal to n only. So you can make all the elements 1 in cost of n. So now the question remains is, can you solve this and can you get the cost which is less than n? So for that, in the given array, let's try to convert all the elements to any number present in the array. Let's try to convert all the elements to 2. So the answer will be total elements minus non, like frequency of 2 into 2. So if you want to convert all elements into 3, it will be total elements minus frequency of 3 into 3. So you can take minimum of all these dot dot dot, and if it goes greater than n, if minimum of all grows greater than n, your minimum of all will be n, because at worst case you can do this thing and make the answer to be n. So this is the solution for the first one. Thank you, have a great night. This is Prajwal signing off.